Hi everyone. In this video, we are going to talk about auxetic structures. So what are the auxetic structures? Auxetic structures are a class of metamaterials that have a negative Poisson's ratio. So as they undergo transverse contraction when axially compressed and show a transverse expansion when axially stretched, in contrary to conventional structures. So if we have a look to this figure, we have a conventional honeycomb and auxetic reentrant honeycomb. For the conventional honeycomb, if we have a subject tension force in this direction, we can see that there is contraction in the lateral direction. Contrary to the auxetic reentrant honeycomb, if we have stretching force in this direction, we have also stretching or expansion in the lateral direction, not contraction. This is an example of the conventional honeycomb, and this is an example of the reentrant honeycomb, which is auxetic structure. So what is the Poisson's ratio? As we all know that Poisson's ratio is the negative lateral strain over the longitudinal strain. And we have here the negative sign to get the Poisson's ratio as positive value. So this is different from conventional systems. Now we have the lateral strain in the same direction as the longitudinal strain. So we have the overall Poisson's ratio as a negative. What are the advantages of auxetic structures? Having a high shear resistance, high indentation resistance, high energy absorption capacity, high blast resistance, and high crash worthiness capacity. So now, what is the typical stress strain curve for auxetics? We have for auxetics three regions for stress strain curve: the elastic region, the plateau region, and the densification region. For the elastic region, increasing the strain will increase the stress linearly. But in the plateau region, we have almost constant stress over the increasing value of strain. And for the densification region, we have a significant increase in the stress value at a point. If we have seen this video, by applying a compression force here in this direction, we have also a contraction in the lateral direction, and this still in the elastic region. Once they start to touch each other, I mean the elements, now we are transferred to the plateau region because now we have permanent deformations, and by increasing the applied load, we can see that there is increase in the stress to overcome this densification. So what are the common types of auxetic structures? We have several types of auxetic structures. For example, the reentrant, arrowhead, origami, chiral, and so on.